Hi and welcome to our pre-calculus. Topic today is using a Pythagorean identity to find solutions in an interval for a trigonometric equation. Problem type 2. Type 2, I think it means that there are some radicals involved in your equation and we need to square, and then because of that we need to check our final answer. However, there are some questions here that look like exactly like what we had before. At any rate, let's get started. The Pythagorean identities, you remember sine squared plus cosine squared equal to 1 is the most famous form of it. But there are two other forms. Tangent squared plus 1 is secant squared, and 1 plus cotangent squared is cosecant squared. Or you can take the one to the other side and have a slightly different form for these identities. Now, how do we apply them? Here, in this question, we see that we have cotangent and cosecant, which are the two ingredients you see here. The problem, it has an additional twist on it by the presence of this radical. The only way to handle that radical at the beginning is to actually take this and square the equation. As a result, so when you square, it's a danger sign that we have to watch for extraneous roots. You remember last time we said if you have an equation like x equal to 2 and you square it, it gives birth to a new root which is x equal to minus 2. Same problem shows up in many places and we have to guard against it by checking our final answer. Okay, squaring this thing gives me 1 plus cotangent of x is equal to cosecant square of x. So that is 1 plus cotangent of x. Cosecant squared is 1 plus cotangent square of x. So the equation that we have, we cancel the 1s. Now we have cotangent square of x minus cotangent of x is equal to 0. I factor a cotangent of x times cotangent of x minus 1. That is equal to 0. Gives birth to two tracks. One is cotangent of x is 0 and the other one is cotangent of x is equal to 1. Cotangent of x equal to 0, if you remember it, perhaps might be more familiar to you by writing cotangent as cosine over sine. If I have an equation like this, a fraction equal to 0, it means the numerator equal to 0, and numerator equal to 0, cosine equal to 0 gives me pi over 2 and 3 pi over 2. Or you might remember cotangent is 0 at these two values. We haven't seen cotangent all that often, and perhaps you might be a little bit rusty in following the argument here, but one way or another we arrive at that. Next, cotangent of x equal to 1. I can reciprocate both sides. That tells me tangent of x is equal to 1. And tangent of x equal to 1 means what? X has to be equal to pi over 4 and pi plus pi over 4, which is 5 pi over 4. Here is a reminder for cotangent, for tangent being equal to 1. Here is my 1. I connect to the origin. Here are my two roots, pi over 4 and 5 pi over 4. Next comes the issue of check. How many of these? So we have to check all of these things. Let's make a list. Pi over 2, 3 pi over 2, pi over 4, and 5 pi over 4. So checking means in the original equation. If you check the final equation, of course it checks it, but the original equation, that's the issue. That is it true that 1 plus cotangent of pi over 2 is same as cosecant of pi over 2? Well, cotangent of pi over 2, that is 0. Cosecant of pi over 2 is 1 over sine of pi over 2. And that's also 1, so this matches, everything works. 1 plus cotangent of 3 pi over 2. Is that same as cosecant of 3 pi over 2? Well, we can say cosecant of 3 pi over 2 is 1 over sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. So on the right hand side I have negative 1. Square root of no quantity is negative 1. So this falls out of consideration. So again, this cotangent is 0. Square root of 1 will be 1 on the left hand side. On the right hand side this is minus 1, so it does not work. Next is 1 plus cotangent of pi over 4, and the right hand side is cosecant of pi over 4. The cotangent of pi over 4 is 1, so we are asking, is 1 plus 1 equal to? Cosecant of pi over 4 is 1 over sine of pi over 4. Sine of pi over 4 is radical 2 over 2, and if you check them, these two quantities are the same, so this checks out. With 5 pi over 4, 1 plus cotangent of 5 pi over 4, is that equal to cosecant of 5 pi over 4? Again, this is sine of 5 pi over 4, that is minus radical 2 over 2. It cannot match square root. Square root of no number turns out to be a negative number, so this is also falling out of favor. The only answers that are acceptable, pi over 2 from this category and pi over 4 from the other category. These two are the survivors, the others fell out. Next, minus square root of 1 minus cotangent of x is the cosecant of x. This is very similar phrasing to that one. If I square both sides, I have minus 1 minus cotangent of x. I square that, and then I square the right hand side as well. Let's remind ourselves that square of minus 1 is just 1. 1 minus cotangent of x comes out of radical, and the other side is cosecant square of x. Cosecant square of x is 1 plus cotangent square of x. So this is 1 minus cotangent of x is 1 plus cotangent square of x. Okay, so sorry, we use that. We use this identity here. 1 cosecant square is 1 plus cotangent square. Okay, ones cancel, bring cotangent to one side, so I'll have cotangent square of x plus cotangent of x equal to 0. Factor a cotangent, becomes cotangent of x plus 1 is equal to 0, very similar to what we just saw. So either cotangent of x is 0 or cotangent of x is equal to minus 1. This one we just had the discussion for it. Possibilities are pi over 2 and 3 pi over 2. This means same as tangent of x being equal to minus 1, and the possibilities there are 3 pi over 4 and 7 pi over 4. Next comes the issue of the check. So one at a time, I put pi over 2. So is it that minus radical 1 minus cotangent of pi over 2 is same as cosecant of pi over 2? Well, what do you think? Cotangent is 0. The left hand side here is just minus 1. Right hand side 1 over sine of pi over 2, that's plus 1. They are not equal. So that falls out. 3 pi over 2, how about that one? 1 minus cotangent of 3 pi over 2. Is that, so there's a question mark you have, is that same as cosecant of 3 pi over 2? As before, this is minus 1, 1 over sine of 3 pi over 2 is also minus 1, so that passed the test. 3 pi over 4, let me see if I can get more space here. So 3 pi over 4 minus radical 1 minus cotangent of 3 pi over 4, is that equal to cosecant of 3 pi over 4? Well, cosecant of 3 pi over 4, this is same as sine of 1 over sine of 3 pi over 4. And that is 1 over radical 2 over 2. Whatever this thing is positive. This side is negative. They can't be equal to each other. I don't need to worry about what is inside the radical and try to match them. On the right hand side you have something that's positive. On the left hand side you have something that's negative. So that falls out of consideration as well. So this is out. How about 7 pi over 4? Is it true that minus radical of 1 minus cotangent of 7 pi over 4 is same as cosecant of 7 pi over 4? Well, this has a better chance because on the left hand side I have minus radical 1 minus cotangent of this, same as the reciprocal of tangent. Tangent is minus 1, minus that becomes plus 1. Is that same as, that is 1 over sine of 7 pi over 4. Well, what's that? 1 over, that is minus radical 2 over 2. So is it true that, let's simplify this thing if you wish, becomes minus 2 over radical 2, and multiplied by radical 2, this becomes minus radical 2, which is exactly what is on the other side. So 7 pi over 4 also passes the test, and 3 pi over 2 and 7 pi over 4 are the two numbers that are passing the test. So when you see that both sides have the same sign, that's a good indication that that's a correct acceptable answer. And here that was the same criterion by which we rejected the answer. Okay, the last of these things is very similar to what we had last time, so I'm not so sure why it's included here, but 1 minus cotangent of x, we square that, is equal to cosecant square of x. So 1 minus 2 cotangent of x plus cotangent square of x. Cosecant square, again, we are cosecant square is 1 plus cotangent square, sorry. Here, cosecant square is 1 plus cotangent square. So now ones cancel, cotangent square cancel, and we are left with twice cotangent of x equal to 0, which means cotangent of x equal to 0. Again, just to remind you, cotangent is cosine over sine is 0, and a fraction is 0. Remember when we reviewed the equation, it said if you have a fraction equal to 0, the numerator should be 0 and denominator should not be 0. cosine of x is 0, then you have pi over 2 or 3 pi over 2. Now we have to check, are these correct answer? Why do we need to check? Because we squared. Pi over 2 is 1 minus cotangent of pi over 2, same as cosecant of pi over 2. What do you think? Are they the same? Well, cotangent is 0, cosecant is 1, and this checks out. How about the other one? 1 minus cotangent of 3 pi over 2. Is that same as cosecant of 3 pi over 2? Well, cotangent of 3 pi over 2 is 0, so this is 1. This is 1 over sine of 3 pi over 2, which is minus 1. 1 and minus 1 don't match. So 3 pi over 2 is out. The only answer of this thing is just pi over 2. That is the only acceptable answer. 1 minus 1 plus radical. We didn't have that, I guess. So let's do as our last example. I take the equation, square it, and I square, minus disappears, radical disappears. I have 1 plus tangent of x. Secant square, what was secant square? It was 1 plus tangent square of x. So ones, we cancel the ones, and then now we have tangent square of x minus tangent of x equal to 0. We can factor this. Tangent of x times tangent of x minus 1 is equal to 0. Two branches come out of this. Either tangent is 0 or tangent is 1. This one gives me 0 and pi. This one gives me pi over 4 and 5 pi over 4. Okay, come to test. 0 minus radical 1 plus tangent of 0. Is that, so is a question, is that same as secant of 0? Well, this side tangent of 0 is 0. This is minus 1. And question, secant of 0 is 1 over cosine of 0. Cosine of 0 is 1, and this is 1. The two don't match. Minus 1 is not same as 1. It's our question's answer, they are not equal. 0 has to be crossed out. How about pi? Minus 1 plus tangent of pi. Is that same as secant of pi? Well, yes. Tangent of pi is 0. This is minus 1. 1 over cosine of pi. Cosine of pi is minus 1. They match. That is fine. How about pi over 4? Minus radical 1 plus, what do you think? Tangent of pi over 4. Is that same as secant of pi over 4? Obviously not, because this side is negative and this side is positive. That's not equal. Pi over 4 is out. 5 pi over 4 minus radical 1 plus tangent of 5 pi over 4. Is that same as secant of 5 pi over 4? Well, secant of 5 pi over 4 is going to be minus radical 2. This is also minus radical 2. This checks out, and so this answer checks out. So our answers are pi and 5 pi over 4. This is a set of acceptable answers. So more practice on tangent, secant, cotangent, and cosecant. More practice on extraneous roots. If you are squaring your equation, you have to check your final answer to see if they satisfy the original equation. Okay, until next time, good luck and God bless.